take a look at this example. D is the image of R. U goes from 1 to 4. V goes from 1 to 4. Under G of UV goes to X is U cubed times V. Y is U over V. Compute the double integral over D of X of Y dA. Okay, D is what we end up with after mapping this region in the UV plane. So 1 to 4, 1 to 4. It's this region here. This is our region R here. It goes to something in the XY plane, some region D here. We don't actually have to figure out what D looks like or anything. You know, we're assuming that this D is our nasty region, and everything's queued up perfectly that this R is our nice region that we're integrating over. So all we have to do here, is replace X with U cubed times V, Y with U over V, and calculate out the Jacobian and throw in absolute value of the Jacobian here, and we're all set. So realize this would be a very difficult problem if I said you have to figure out what this region looks like in the XY plane. It's going to be some really messy region, and then you have to integrate over that. That's going to be a mess. We are far, 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 far happier to integrate over in the UV plane over this nice region. Okay, that's the prologue. Let's get down to business here. The Jacobian, all right, in this notation in this problem here. The partial derivative of this with respect to, of x with respect to u is 3u squared v. The partial derivative of this with respect to v is u cubed. The partial derivative of y with respect to u is 1 over v. The partial derivative of y with respect to v is negative u over v squared. And so when we do this times this minus this times this, we get this times this is negative 3 u cubed v over v squared is over v minus u cubed over v. Hey, we can combine this together to be negative 4 u cubed over v. Okay, so our double integral is going to be u runs from 1 to 4, v runs from 1 to 4. That's really nice. We replace x with u cubed v. We replace y with u over v. And then we need to throw in, this is something that's a common little mistake. This is why I chose this problem. We throw in not the Jacobian, but the absolute value of the Jacobian. So in our problem, u and v are both positive. Negative 4 u cubed over v will be negative. So absolute value of negative 4 u cubed over v dv du. The consequence here is that this becomes positive 4 u cubed over v. Okay, so u cubed v plus u over v times 4u cubed over v dv du. So that's a very common mistake that, you know, forgetting to slap on absolute value bars is probably the most common mistake I expect on a test on this problem. Okay, so let's just distribute out the multiplication here. So we would have 4u to the 6 times v over v, okay, 4u to the 6 plus 4u to the 4th over v squared dv du. Integrate this with respect to v, we end up with what? 4u to the 6th v minus 4u to the 4th over v. Plug in v from 1 to 4. U is equal from 1 to 4. 4 times 4 is 16, u to the 6, minus 4 over 4, u to the 4th, minus plug in 1, 4u to the 6, minus 4u to the 4th. Get my parentheses here, and I think this is a good place to stop. You can finish off the problem if you want to. The important thing is realizing that this looks weird, but we don't have to worry about what the region looks like. We just use this awesome theorem here.